Hello everyone, I welcome you all to the Infinity Vision platform. Right now I'll be doing one such question that came in your JEE main examination. This question came on 1st September 2021 and this question came on second shift. So इसी साल का question है ये. So let us see this question first. Question says a square loop of side 20 centimeter and resistance 1 ohm is moved towards right with a constant speed V0. So that means you have been given this square loop. Okay. And whose side is 20 centimeter. And the square loop is moving inside the magnetic field. Okay, and its resistance is also 1 ohm. It is connected along with the additional resistor external circuit just like this. So the right arm of the loop is in the uniform magnetic field of 5 Tesla. So this right arm, it is in the uniform magnetic field of 5 Tesla, which is given to you. The field is perpendicular to the plane. The field is perpendicular to the plane. As you can see, the field is inside into this plane, okay, of a loop and is going into it. The loop is, and this loop is going towards the right with the speed of V0. So the loop is connected to the network of resistance, each of value 4 ohm, which is already given to you. So what should be the value of V0? What should be its loop speed, so that the steady current of 2 milliampere flows within the loop? So that means we already know that this is a case of motional EMF. Whenever this loop will move on within this external magnetic field, the external magnetic field, a motional EMF will be produced because magnetic flux linked through this area changes. So you'll get an induced EMF over here. Okay, and this induced EMF, we already know that if this loop is just like this and it is placed within magnetic field, and if it is moving like this with velocity V0, this phase, this length would develop induced EMF, or that is called motional EMF, because of which current will flow within the circuit. So that means at initial position the loop must be like this. It was entering the magnetic field, the perpendicular magnetic field. So while it is entering the perpendicular magnetic field with the speed V0, the motional EMF developed within its terminal is given by expression. Motional EMF is given by the expression E is equal to BL into V, where V is the speed with which this conductor is moving, L is the length of this conductor, and B is the B is the magnetic field in which it is placed. Okay, so this induced EMF is equivalent to BL, we already know. So that means, and what about the direction? You can easily find out the direction of induced EMF by using right hand palm rule. What it says, you have to place this whole fingers in the direction of magnetic field, and this thumb would be in the direction of motion of this conductor, because since conductor is moving like this, it should be in the direction, your thumb should be in the direction of conductor. So this palm indicates the point of polarity, positive polarity of the induced EMF. So if it is positive, so this must be negative. So that means this upper surface would have a polarity of plus, and lower surface would have a surface would have a polarity of negative. So that means it will behave like a cell just like this, whose polarity is the positive terminal is upward and negative terminal is downward. So this expression can be, and whose EMF is given by BLV. Okay, this we already know. So that means if it is moving just like this whole loop is moving inside the magnetic field. So that means its induced EMF is developed, whose magnitude is this, and a current will develop within this loop, and this current direction would be just like this. Okay, so this is the direction of current, induced current, that will flow within this loop, and its resistance is already given to you, which is 1 ohm. So let us visualize this question, and see the circuit will become like this. Since these P and Q this terminal as well as this terminal along P and Q, this 8 ohm and 8 ohm would be parallel, because these two 4 and 4 ohm are in series. So it would be equivalent to 8 ohm, and this 8 ohm would be parallel with this 8 ohm. So the parallel combination, so the resistance along P and Q would be 8 parallel with 8, which is nothing but 4. So this whole circuit would be like this. This is P and this is Q, and this would be like this. Resistance of 1 ohm. So this is the circuitry that you will be getting as this point is Q, this point is P, and it has got a resistance of 1 ohm. This loop has got a resistance of 1 ohm, and its induced EMF is E. So what should be the current supplied within the circuit? It would be equivalent to I equal to V by R. V कितना है? This is it, E. What is resistance of the circuit? So resistance of the circuit is 4 plus 1, which is 5. So it would be equivalent to BLV. What is B? B is 5 Tesla. What is length? Length of this conductor is, what is it? Length is 20 centimeters. So it would be equivalent to 20 into 10 raised to power minus 2. Okay. B into L into V. What is the speed with which it is moving? It was V naughts divided by this 5. This current, induced current, is already given to you, which is 2 milliampere. Solve this expression. 5 से 5 cancel. Ultimately you will get the value of V naught, which comes out to be 1 centimeter by per second. So this is the expression that you must get. So that means second would be our correct option. First of all, you need to know about the emotional EMF, then only you would be able to solve these questions. I hope this question is clear to everyone. Thank you.